Hey, Alex, you know how sometimes you hear about something and it just totally blows your mind? Like, I was reading about this Dr. Katanya Kuntz, and everything she's involved in, it's just wild.
Oh, absolutely, Audrey. Dr. Kuntz is a force, right? She's like at the forefront of so much, especially with the quantum computing stuff at the University of Waterloo, and then this QEI-SAT mission for Canada. It's truly pioneering, isn't it? Like really truly pioneering.
Yeah, exactly. The QEI essay, that's the quantum internet thing, right? Like a global quantum internet? That sounds like something out of a sci-fi movie, you know?
It totally does. But it's happening, 2026 actually. This microsatellite, a low Earth orbit one, is all about quantum key distribution from space. Basically, they're demonstrating how to send virtually unbreakable encryption keys using quantum mechanics. And the cool part is, quantum info, it can't be copied without changing it. That's huge for security.
Wow. So, like regular internet security, it has its limits. But this is different because it uses what? Individual photons?
Precisely. The traditional fiber optic stuff, it works, but only for about 200 to 500 kilometers because photons just, well, they get absorbed. QEIS, though, it's designed to send individual photons from ground telescopes up to the satellite, which then measures them. It's going to enable secure comms across Canada, potentially linking ground stations. It's a game changer, really.
Okay, so it's bypassing the distance problem by going into space. That's smart. But like, how do they actually do that? What's the secret sauce, you know?
Well, the secret sauce, as you put it, involves some pretty sophisticated tech. They're using what's called a reference frame independent quantum communication for satellite-based networks, or RFIQ quantum source. This was a big collaboration between Canadian and UK researchers, and it's actually ready for integration into the satellite right now. It's all about creating those secure quantum links.
That's wild. So, like, Canada's a pioneer here, but are other countries also playing in the space?
Oh, absolutely. It's a global race in a way. China, they've actually already done this with their Michia satellite. They've conducted quantum encrypted video calls between continents. And the European Space Agency, ESA, they're working on their QKDS-SAT project too, partnering with folks like Honeywell UK. It's a huge international effort, and 2025 is even the International Year of Quantum Science and Technology, so it's really picking up steam.
Wow, so it's not just a Canadian thing. It's truly global. That's incredible. Okay, so quantum internet, mind-blowing. But then I saw something about Dr. Kunz also touching on quantum biology. Like, how does quantum mechanics, which sounds super high-tech, fit into like actual living things?
That's such a great question, Audrey, and it's fascinating. Quantum biology is really an emerging field, exploring how quantum principles apply to biological processes that classical physics just can't quite explain. Dr. Kuntz, she points out that photons, those light particles essential for quantum communication, are also fundamental to life itself. Think photosynthesis, vision, right?
Oh, wow. I never thought of it that way. So, are there like actual examples of quantum effects in biology, or is it still mostly theory?
Oh no, there are actual examples, like enzymatic reactions, quantum tunneling. It's recognized as a crucial mechanism that dramatically speeds up enzymes, which are vital catalysts. And get this, bird navigation. The radical pair mechanism involving cryptochrome proteins in birds' retinas and entangled electrons helps them sense Earth's magnetic field to navigate. Intriguingly, we might even have a version of that in human metabolism.
You're kidding me? So, birds use quantum mechanics to find their way? And we might have some hidden quantum senses too? Okay, bird navigation is crazy, but then there's like the ultimate question, quantum consciousness. Is that even a real thing, or is it just pure science fiction?
Ah, the big one. It's definitely an active area of scientific inquiry, Audrey, though it is highly speculative. Scientists at the University of Calgary, for instance, they've done a study suggesting quantum entanglement of electrons and radical pairs could be involved in how anesthetics like xenon affect consciousness. Their model is actually consistent with those bird magnetoreception theories.
So, like, our brains might actually be doing quantum stuff? That's just wild to think about. How far along is that research?
Well, the boundaries are really blurring here. Theories like Penrose-Hamerloff's orchestrated objective reduction model, they propose that microtubules within neurons might act as tiny quantum computers. And recent findings like superradiance in cellular frameworks and entangled photons from nerve cell insulation are making researchers reconsider how quantum chemistry influences the brain. The University of Calgary, they're a huge hub for this, and breakthroughs could totally reshape our understanding of consciousness in decades to come.
Whoa. So, like, my brain is a quantum computer? That's something to chew on.